In this video, I'll be discussing what an inductor is and also go through an example of inductor in an RL circuit. An inductor is a device that temporarily stores energy in the form of a magnetic field and is used to resist sudden changes in current. As seen in this image, inductors are commonly manufactured in the form of coils of wire. One of the basic properties of electromagnetism is that when you have current flowing through a conductor, or in this case a coil of wire, you will create a magnetic field surrounding it. The strength of this magnetic field is directly proportional to the amount of wire that is coiled up, and as such the value of current passing through the coil. Therefore, if you have a lot of wire coiled up, you will have a stronger magnetic field. When current is applied to an inductor and first starts to flow through the coil, a magnetic field begins to expand. It will continue to do so until it reaches a particular stage, where it will stabilize and therefore some sort of energy is stored in the magnetic field. This stage is known as steady state. On the other hand, when current stops flowing, the magnetic field begins to collapse. Eventually, the magnetic energy will be turned back into electrical energy. The most important principle to remember about inductors is that the current in an inductor cannot instantly change, and it instead lags by a particular amount of time. Now I'm going to run through an example of an inductor in an RL circuit, which as the name suggests is a circuit composed of resistors and inductors. In the diagram below we can see that we have a circuit with a 60 volt battery connected in series with a 25 ohm resistor and a 3 Henry inductor. We are asked to determine A, how long after the switch is closed will the current reach 99.3% of its maximum value, and B, what will the current be after 80 milliseconds. So starting with part A, when we close the switch being T equals 0, and apply current to the circuit, the current will instantly flow through the circuit. However, the inductor will hold back this initial surge and takes a particular time to flow. This time is called the time constant, which is equal to L over R. Therefore, for this circuit, the time constant is equal to 3 henries divided by 25 ohms, which equals 0.12 seconds. The time it takes for the current to reach its steady state is equivalent to 5 time constants. Therefore, for part A, the time it takes to reach steady state is 5 multiplied by 0.12 seconds, which is equal to 0.6 seconds. Now for part B, we have to find the current of the inductor after 80 milliseconds. The equation associated with this is expressed as current as a function of time is equal to the current in the circuit multiplied by 1 minus e to the power of minus t over the time constant. So therefore we have I as a function of time is equal to 80 milliseconds equals 60 over 25 multiplied by 1 minus e to the power of minus 80 milliseconds over 0.12 seconds, which is equal to 1.17 amps. Thank you.